Hey, what's going on, guys? I wanted to make a video covering your Unit 8 test review. It is our last test of the semester, last unit test of the semester, minus the performance final and the final exam. But hey, listen, I hope this helps. Man, let's really try it out, man. Let's put that extra effort into it, man, to finish up with a bang, all right? Let's go ahead and get started. Alright, man, starting off 1 through 4, we got a couple definitions we got to put in. Or not even definitions, just how-to steps, alright? So I'm going to type them in, and you review them, alright? Alright, how do you find the zeros of a rational function? Alright, here are the rules, guys. I listed them out, man. Read over them. Alright, I'm going to just jot them real quick. For the zeros, make sure you factor all the polynomials. Look to cancel out any factors after you cancel out the wholes. All right. And look, I put this part right here because I don't want there to be any confusion. But let's say hypothetically you don't have any wholes, right? Nothing canceled out. That's okay. Any remaining factors in the numerator are zeros. You set them equal to 0. All right. And solve for x. How do you find the wholes? You factor all the polynomials. Look to cancel out any factors. Any factors you cancel forms a whole. Oh, that's a typo. Forms a whole in the function.
I just like the sound.
Take the cancel factor, set it equal to 0, and solve for x. Okay. How do you find a horizontal asymptote of a rational function? Look at the original function before you factor, guys. That's before you factor. If there's a larger degree at the top, that means there's no horizontal asymptote. If there's a larger degree at the bottom, that means your horizontal asymptote is y equals 0. But if your degrees are the same, then divide the leading coefficients of the top and the bottom. Alright, so that's your rules for the horizontal asymptote. And then finally, for your vertical asymptote, factor all polynomials, look to cancel out any factors. Alright, that's again, maybe you don't have anything to cancel. Alright, after you cancel out the wholes. Alright. Any remaining factors in the denominator are your vertical asymptotes. Set that equal to 0 and solve for x, okay? Alright, let's look at number 5 here. Alright, so number 5 here says, what are the zeros and wholes of this polynomial right here? Well, again, if you use the rules that we have up above, first of all, you got to factor everything. So when we factor that top, that's the difference of, that's a perfect square trinomial. So you have x minus 6 times x minus 6. Dang. So again, that's x minus 6 times x minus 6 all over x minus 6. All right. Now, what you have here is, well, first of all, you got to look and see if you can cancel anything. All right. So can we cancel anything? Yeah, we can cancel that x minus 6 right there. So that's going to give us a whole. All right. So we take that factor, set it equal to 0 and solve it. You get x equals 6. That's where our whole is. All right. Now, I know you're thinking, oh, wait, we got a 0 right here too, right? X minus 6. All right. But guys, notice it's the same thing as the whole. All right. So rule of thumb is not 0. The whole trumps all. Alright. The whole wins. Alright. It's like a black hole. If you put a 0 inside of a hole, it absorbs it. Alright. So yeah, there's no 0. Alright, there's no 0. Because when you solve that, you'll get the same thing, and that's not true, okay? So there's only a hole right here. Alright. For this next example, it says, what are the zeros and holes? So again, we're going to factor this thing right here. X plus 4 and x plus 2. And that's divided by x plus 2. So again, ask yourself, is there any factors that you can cancel out? And there is. You can cancel out x plus 2. That's going to be our whole. We take that factor, we set it equal to 0. And solve it, you get x equals -2. Now, we look at the remaining factor in the numerator. We're going to set that equal to 0 and solve it. And we're going to have x equals -4. Alright. So now we're going to identify all the asymptotes. Before we factor, let's find the horizontal asymptote. The horizontal asymptote, we look at the degree at the top and the degree at the bottom. Well, the degree at the top is 2, the degree at the bottom is 1. Alright, so it's larger at the top. So remember when the degree is larger at the top, there's no horizontal asymptote. Now, for the denominator, you have, for the horizontal, for the vertical asymptote, I'm sleepy. You got to factor everything. X plus 3 all over x minus 3. And at the bottom, you're going to have x minus 2. So anyway, if you look at the denominator, you'll notice that there's only one factor remaining in the denominator, and there's nothing to cancel. So for our vertical asymptote, we're going to take what's remaining in the denominator, that factor, set it equal to 0 and solve it, and you get x equals 2. Alright, so that's our vertical asymptote. Over here, identify all asymptotes. Again, for the horizontal asymptote. At the top, the degree is 1. At the bottom, the degree is 2. When the degree is larger at the bottom, the horizontal asymptote is going to be y equals 0. Now, we factor everything. We got to find our vertical asymptote. That's not what I want. X plus 4, x plus 5. I just like the sound. There we go. So we got a hole there that cancels out, and then we have a factor remaining in the denominator. We'll take that factor that's remaining in the denominator and set it equal to 0 and solve. Alright, so the vertical asymptote is going to be x equals -5. Alright, let's see here. Alright, so now let's look at number 9. Number 9 says find zeros, vertical asymptotes, and sketch a graph of the function by making a table of values. Okay. So let's go ahead and dig in. First, let's go ahead and let's look for the horizontal asymptote first. That way I don't have to factor anything yet. Well, the degree at the top is larger than the degree at the bottom, so there's no horizontal asymptote. Alright, now I'm going to factor everything, and that gives me x plus 3, x plus 2, all over x plus 3. Now, I can cancel out x plus 3. So that tells me that my whole is x equals -3 because I can take that, set it equal to 0 and solve it. Solve it, you get -3. But see how there's no more factors in the denominator? That means that the vertical asymptote has none either. Alright, none, no vertical asymptote. Now for the 0. There's this factor x plus 2 left in the numerator. So if we set that equal to 0, we're going to get x equals -2. So those are all our critical values, okay? Our critical points. Now, we're going to grab this thing. Yep. And it's easy, man, because that canceled. There's only this there right here. So I'm just going to pick points. Like if I pick 0, I have 0, 2. So 0 up 2. Let's see here. If I plug in 1, I'll get 3. So 1, 3. If I plug in, like, let's say 8. I have 8 plus 2 is 10. So 8, 10. So 8 up 10. Like that. And then let's do a negative number. -8. -8 plus 2 is -6. who's negative 8, negative 6 right there. So negative 8, negative 6. Boom. So there's my deal. All right. Remember, there's a hole, though. There's a hole at x equals negative 3. So if I plug in negative 3, all right, negative 3 plus 2 is negative 1. That's where the hole is, right? That's your hole. All right, so there's a hole right here. Well, here, let me sketch the line real quick. There is a hole right here, negative 3, negative 1. There's our hole right there, okay? All right. All right, so real quick, looking at this problem right here. Let me start with the horizontal asymptote again, just because I don't have to factor yet. So I have the degree is 2 at the top and 2 at the bottom. So that means I need to divide the leading coefficients of 1 and 1. So that gives me a horizontal asymptote of y equals 1. All right. Now, let's go ahead and look at the what's factor. So at the top, you're going to have x minus 9, x plus 9, and x plus 1. At the bottom, you have x plus 9, x minus 9. All right. So now, is there anything we can cancel? Yeah. X plus 9. So that's going to be our whole. Take that factor, set it equal to 0, and solve it. X is negative 9. Next, are there any vertical asymptotes? Well, you look here in the denominator, there's still a factor remaining, x minus 9. So we set that equal to 0, x is 9. And then at the top right there, you have a remaining factor, which is x plus 1. Set that equal to 0, x is negative 1. Alright, there's your 0. So let's see here. 0, x equals negative 1. Whole. Hey, make sure you guys, man, indicate your variable. That's x, that's x. This is y. Now, domain and range. These are critical points. The main thing to remember, though, is this value here and the vertical asymptote are x restrictions. They affect your domain. Alright, and this one is a y restriction for your range, okay? X description, y. X restriction, y restriction, okay? So now let me move this out of the way so I can have space to write. For the domain, if you remember, well here, let's graph this thing first. Put your asymptotes on your paper. Always do this, guys. Don't go to the calculator first, man. Just put them on there. Vertical asymptote at 9. So here's 9. Not quite, but that's 9. Alright, and then we have a horizontal asymptote at 1 right here. Alright. And then we have a 0 at negative 1. So right here. Right there. So now, when you grab this thing, guys, it's just, you can use points for your table. But I know it's going to look something like this. Oh yeah, where's that hole at? Negative 9. So there's a hole right here. I know the graph looks something like this though. And there's a hole right here at negative 9. Hole. Make sure you put your hole in your paper. Anyway, for the domain, you have negative infinity way out here and positive infinity way over here. But remember, your x restrictions, your 9. Oh, the hole is at 9. No, the hole's at negative 9. So you have your hole at negative 9. and you have your vertical asymptote at 9. So that's our domain right there. We have negative infinity to negative 9, negative 9 to 9, and 9 to positive infinity, like that, okay? And I'll just literally go from here to here, here to here, here to here, okay? Just like that. Alright, now let's talk about the range.
I just like the sound.
For the range, your Y restriction, this is your only Y restriction right here. Alright, so you have negative infinity down here, and what I mean by that is, see how these are negative numbers, negative 1, negative 2, negative 3, negative 4, negative 8, negative infinity way down here. And you have positive infinity way up here, because the range are the Y values, it's the Y axis. So 1, 2, 3, 4, 5, positive infinity way up here. Well, you only have one Y restriction, and it's right here. It's the whole, the horizontal asymptote right here, and that's at 1. So that's your range from negative infinity to 1. And then again from 1 to positive infinity. Alright. Now you can see it because look, listen, as you go right here, the graph doesn't exist there. You know, so awesome. Alright, so now what we got is we're gonna identify the domain, the range, the asymptote, the holes, and the function, and then we're gonna draw a graph. For this first part right here, again, we're going to identify the horizontal asymptote first. Notice it's larger at the bottom. So when it's larger at the bottom, we can say that the horizontal asymptote is y equals 0. Now we're going to factor. We have x minus 5 at the top. And at the bottom we have, let's see here, x minus 5, x minus 3. Alright, right there. So now, what we're going to do is, let's cancel out the x minus 5. That's going to be our whole, so x equals 5. And then we have in the denominator, x minus 3 is remaining. Therefore, we set that equals 0, and we have x equals 3. Alright. Now, remember, there are two types of x restrictions. These are your x restrictions. So that'll be a part of your domain. And then this one right here is your Y restriction. Alright, Y restriction. So what we're going to do is we're going to look at the graph here. Alright. And so let's put our asymptotes on the graph. We have a vertical asymptote at 3. So 1, 2, 3, x is 3. Alright, there's our vertical asymptote. And then we have a horizontal asymptote at 0, y is 0. So right here. Alright, we don't go up or down, we just stay right here. So y equals 0 right there. Alright, and then we have a hole where at 5. So 4, 5, there's a hole right here, okay? So we grab this thing like so. Oh, and I notice, guys, there's no zeros, and the reason being there's no zeros is because the horizontal asymptote is on the x-axis, so you can't have zeros on the x-axis. Alright, because y equals 0. Alright, so there we go. There's our graph. For the domain, guys, remember you have negative infinity way out here and positive infinity here. And then look at your x restrictions. You have 3 and then 5. Alright, and just remember, just write them. Oh, it's a hole somewhere in here. There's a hole. Just write it from least to greatest. Alright, least to greatest. 3 comes before 5. So there we go. We have negative infinity to 3. Alright, you can do this union symbol. Alright, or a comma. Doesn't matter. Same thing. 3 to 5. And 5 to positive infinity right there. Alright. That's our domain. For our range, Remember, you have negative infinity way down here at the bottom. See the -1, -2, -3, -4, -5, negative infinity. And then you have positive infinity way up here. All right, then you have a y restriction of 0. All right, so that's going to be our range from negative infinity. Always go from least to greatest, negative to 0. And then from 0 to positive infinity. All right. And that will conclude that problem right there. Now, let's go back to look at number 12. All right. Real quick, man, let's go ahead and identify the horizontal asymptote. They're the same value. All right. They're the same degree. So we're going to divide the leading coefficients. This one's 1, this one's 2. So we have y equals 1/2. Y equals 1/2. All right. And now we're going to factor this to have, let's see, x plus 4, x minus 1, all over 2x times, and I factor out the GCF down here, so factor out 2x, you have x minus 1. All right, see, look, 2x times x is 2x squared, 2x times -1 is -2x, so I factor out the GCF. So anyway, can I cancel anything? Yes, sir, I can. X minus 1, that is going to be my whole. All right, and then for my vertical asymptote, I have this factor remaining at the bottom. So I take it, set it equal to 0 as we do all our other factors, and solve. Well, 0 divided by 2 is 0. So the vertical asymptote is 0. All right. And then we have a factor remaining in the numerator. All right, so we set that equal to 0, and that's going to be -4. That's our whole. All right. So remember, domain restriction. All right. Range restriction, or y restriction right there, okay? All right, so for our domain, guys, I mean, I really don't have to graph it to even figure it out, guys. Like, I just know the restrictions. So negative infinity to 0. 0 comes before 1. All right, then you have 1 to 0. And then you have, I'm sorry, not 0 to 1. I definitely wrote that backwards. So let me erase that and fix it. Sorry about that. So again, 0 to 1. And then we have 1 to positive infinity. There we go. Right there. And then our range is going to be from negative infinity to 1/2 and 1/2 to positive infinity. Like so. Like so. Alright, so I'm going to graph it real quick just so you can see it. Alright, so here's your graph. There's your asymptote right there. Your vertical asymptote in blue, your horizontal asymptote in green. Your holes right there in purple. Alright, and then, excuse me, your 0 is there in purple on the axis. And your holes right there at 1. Alright. Anyway, for increasing and decreasing, guys, it's as simple as tracing the line. Alright, so you're going to trace the line, and here's what I mean by that. If I trace this line, right, ultimately what am I doing? I'm going down, so that's a decrease. And even when I trace this one, I'm going down right now. You always go from left to right, alright? Left to right. So trace the line, we're going down. Trace the line, we're going down. So that means increasing, there's none. But for decreasing, this, once you establish if it's an increasing or decreasing, well, your answer is going to be the same as your domain. We established that this is decreasing. So our decreasing is going to be our domain. Zero to 1. And 1 to positive infinity. Alright, so there we go right there. Alright, and then in behavior, man, when you think about the function, you're talking about y, the y value. All right, y. So how high up can this go? Well, it can only go to right here. Y equals 1/2. All right, you can't go past that. It's a ceiling. All right, you can't go higher than the roof. All right, and even on the other side, you can't go lower than the floor. All right, that's the floor. All All right, so you can't go lower than the floor. All right, so 1/2. All right, or if you just remember that little bit right there, that's your Y restricted. That's your Y cap right there. All right, right here, man, it says Archer peer leaders are going on a conference in Palm Springs, California. The trip is going to cost $875 per peer leader plus $1,500 deposit of each, which each student must pay equal part. So we need to make this equation. Well, we know for a fact everybody's going to pay $875. All right, but we've got to split up $1,500. So we're going to divide that by X because we don't know how many people are actually going yet. You see what I'm saying? So there's our equation. Now, for the sake of finding the horizontal asymptote, what I'm going to do is I'm going to write this where it has common denominators. If I wanted common denominators, I'll put X under here, which means I have to put X up here. All right. So what we end up with is 875X plus 1,500 all over X. Now it has the same denominator. So right here where it says find the total average cost per person if 12 peer leaders plan to go on a trip. What we would do, first of all, you have to identify that X is 12. All right. So now X is 12, so we go 875. All right, I'll use this one right here. Plus 1,500 divided by X. And when you do that, you're going to get 1,500 divided by 12. It's going to be 125. So 125 plus 875 is going to be 1,000. Each person is going to pay $1,000. All right. Let's jump down here. We have the number N of daily customers to a new restaurant at the Mall of Georgia can be modeled by this function right here, where X is the number of days a new restaurant has been open. All right. So it says, what is the horizontal asymptote of this function and what does it represent? Well, everything has a common denominator. So we have degree of 1 at the top and degree of 1 at the bottom. Remember, horizontal asymptote, we look at the degrees. So since we have 1 divided by 1, since we have the same degree, we divide the leading coefficients. So you have 215 divided by 1, and that's going to be 215. So Y equals 215. All right. And then it says, what does that mean? All right. Well, what that means is that is the average number of people that will visit on a day. All right. So now, anyway, it says to the nearest integer, how many customers can be expected after 2 months of the restaurant being open? So 60 days. So in this case, X is 60. All right. So we plug it in. We go F of 60. All right. So we plug it into the equation. I have 215 times 60 plus 75 divided by 60. All right. And when we do the math on this, we get 216.25. All right, right there. All right, it's number 14, man. We're almost done, guys. We got a couple problems right here to do, and then that'll be it. For this first one, make sure you understand this is just adding. All right, we're just adding. All right, they have different denominators, so we gotta get common denominators. Here we're going to put this denominator over here, so we have X plus 4, and since we added at the bottom, we got to put it at the top. And then over here, we have X plus 4. We need X minus 4 over here. All right, so let me try that again. X minus 4. And if I do it at the bottom, I have to do it at the top. So now at the top right here, we need to FOIL that. So we have X squared minus 4X minus 3X plus 12. So that's going to give us X squared minus 7X plus 12. And then right here, distribute the 5. So it's going to be positive 5X plus 9 all over X minus 4 X plus 4. Now simplify the top. That's going to be X squared minus 2X negative 7X plus 5 is negative 2X. All right, and then 12 plus 9 is going to be actually, I realized I made a mistake. Look at that. Check this out. 5 times 4 is 20. So now we have 12 times 20. That's going to be 32. All right, right there. All over X minus 4, X plus 4. Now, this right here doesn't factor. There are no factors of 32 that I add to give me 16. So now, that's it, man. You know, the only addition to this problem could be if I was asked where is it undefined. Well, you would take the denominator, set them not equal to 0, and solve it, and you get x not equal to 4 or -4. You know what I'm saying? But that's it, man, when you add them up. All right. Now, let's look at number 16. I'm going to clear this out real quick. All right. So for this problem here, again, we need to get common denominators. So over here, we need to multiply by 5. So we'll do it at the bottom. We're going to do it at the top. And over here, we're going to multiply by x minus 1. So we can have the same denominators. All right. So now, right here, distribute the 5. You have 5x squared plus 4x. Oh, I'm sorry. I got to distribute the 5. 5x squared plus 20x minus 60. All right. And then right here, I'm not going to touch that negative yet, but I'm going to FOIL these two. All right, I'm not going to touch the negative. I'm going to put these in their own parentheses. So that's x squared minus 1x plus 3x. All right, minus 3. So that simplifies to give us x squared plus 2x minus 3. All right, all over 5 times x minus 1. Now we need to distribute the negative. So it gives us 5x squared plus 20x minus 60 minus x squared minus 2x plus 3. All right. Now, combine like terms at the top. We have 5x squared minus x squared. That's going to be 4x squared. We have, let's see here, 20 minus 2x. 20x minus 2x is going to be 18x. And then we have negative 60 plus 3. That's going to be negative 57. Oops, 57. That looks all the same. Negative 57. All right, all over 5 times x minus 1. All right, and if we factor the top, we won't get a real solution, okay? So I'm going to actually end this right here. The only addition to this problem I can add is where it's undefined. Well, that's a constant, so we can't set the constant equal to 0. That doesn't make sense, okay? All right, that's true. All right, but this one we can solve for x right there. So set it not equal to 0, solve it. X cannot be positive 1. All right, cannot be positive 1. So, all right, moving along. All right, we have 2 more examples. Well, all right, remember this type of problem, right? See the equal? All right, so right here we have a whole equation. We're going to solve for the variable r. First, we start by finding the LCD. Remember, the LCD would be the same thing as if I was trying to get common denominators, right? R plus 2. All right, like r plus 2 would have to be the denominator. So the LCD is r plus 2. Now, don't write this here, and I'm going to show you why. We're going to eliminate, we're going to use this to eliminate the fraction. So what I do is I multiply by r plus 2 at the top, all right, to every numerator. All right, every single numerator, even this negative 6 is a numerator because remember that's over 1, so that's a numerator, right? So what happens right here is r plus 2 cancels, so I'm left with 12r. And over here, r plus 2 is going to cancel again, so I'm left with 4. And right here, I have negative minus 6 times r plus 2. Now there's no more fractions, and we can just solve for the variable, okay? Well, right here, I'm going to distribute the negative 6, excuse me, to r plus 2, so that gives me negative 6r minus 12. I just like the sound of it. Now, I solve like terms. I'm going to add 6r over here, so that gives me 18r. And over here I have 4 minus 12. Well, 4 minus 12 is going to be a negative 8. Now I just solve for r by dividing by 18 on both sides. And when we do that, we get r equals, we're going to reduce that. So Negative 8 divided by 2 is going to be a negative 4. And 18 divided by 2 is going to be 9. So R equals negative 4 over 9. And finally, our last problem. Again, we need to find the LCD. Well, if I wanted common denominators, first of all, we need to factor all denominators. All right, so if I factor this one, d squared minus 4, that gives us d plus 2 over d minus 2. So I'm just going to write it out so you can see it. All right, now, because I have, all right, I got to find my LCD. All right, so to find my LCD, all right, this, I look and see what would make all this one single deal, man, one common denominator. All right, well, this one would need d plus 2. I mean d minus 2, sorry about that. D minus 2. Don't write this down. I'm just showing you. This one would need d plus 2, right? And then that one has both already. So that least common denominator, guys, see now everything's the same as d plus 2 and d minus 2. All right, so let me clear this out because I don't want to make mistakes. And the purpose of this is to get rid of the denominators. So now we're going to get rid of the denominators by multiply the LCD at the top and the bottom. So here we go, d plus 2, d minus 2. All right, even right here, d plus 2, d minus 2. And over here, we're going to do d minus 4. D squared minus 4, sorry. And the reason I'm doing that, guys, is because remember, this right here, this factor right here is this, right? Those are the same thing, I just factored. All right, so anyway, right here, the d plus 2 cancels. So I'm left with 2 times d minus 2. Right here, the d minus 2 would cancel. So I'm left with 8 times d plus 2. And right here, the whole denominator will cancel, so it equals 14. So there's no more fractions. So now all we got to do is solve for d. I'm going to distribute the 2 and distribute the 8. And then combine like terms. 10d equals, oh, not 10d equals, but 10d plus 12 equals 14. Now we're going to subtract 14 on both sides. Subtract 12 on both sides. I don't know what I'm thinking about right now. So 10d equals 2. And then we divide by 10 on both sides. And d equals 1/5. All right, d equals 1/5. All right. Well, hey man, that concludes your video. I really hope this helps you study. All right. Remember, let's do our best, man. It's our last unit test of the semester. So, catch you later and good luck.